Hi everyone, welcome back. Today we are on day 3, 10.2 notes, and we are going to be talking about the law of sines. So with the law of sines, this is going to be helpful when we have any non-right triangle and we're trying to find missing information. So either a missing side or missing angle. And the law of sines will be used for angle, angle, side, angle, or side, side, angle. However, it's important to note if it is a side, side angle, there is going to be an ambiguous case. So what that means is that we can either have one triangle, we can have two triangles, or we can have no triangles. So right now that's probably a little bit confusing, but we will work through some examples with that. Also, with the law of sines, we always have one set of corresponding sides with an angle. So what I mean by that is that you would have to be given angle A and side A, or you would have to be given angle B with side B, or of course the last one's angle C with side C. So you need at least one pair of corresponding information. Okay, so in example 1, we have the measure of angle A is 36 degrees. Let's always try to label our triangles. Angle B is 50 degrees. And then side B is going to be 12.51 centimeters. Okay, so we do have matching corresponding angle and side information. And we are looking to find side A and side B. Okay, so using our law of sines, we're always going to begin with the information that was given to us, so our corresponding angle and side. So we can say sine 50 degrees over the corresponding side, which was 12.51, is going to be equal to, well, we have angle A, so let's work with sine of 36 degrees over side A. That's what we're looking for. So from here, we're just going to use some cross multiplication. So 12.51 times sine 36 degrees is equal to A times sine 50 degrees. Okay, so then A is going to be equal to 12.51 sine 36 degrees divided by sine 50 degrees. So we do want to type this whole thing into our calculator rather than solving bits by bits, because we don't want to worry about any rounding issues. So make sure that you are back in degree mode for your calculator. And when you substitute this in, you should get that A is approximately 9.6 centimeters. Okay, so we found A, now we have to find B. Well, we need to know, this should say C. So hopefully on yours that is fixed, mine says B. All right, so we want to find side C. So first we need to know what the measure of angle C is. Well, a triangle is always going to have a sum of the angles being 180 degrees. So 180 minus 50 minus 36, and that's going to give us 94 degrees for angle C. Okay, so again, we always start with what was given to us. That was angle B and side B. Then we know that angle C is 94 degrees, and we're trying to find that side. So once again, go ahead and use your cross multiplication. And when we substitute that into our calculator, we should get that C is approximately 16.3 centimeters. So I have found A and C. Okay, number 2. If A is equal to 29.45 centimeters and B is 30.12 centimeters, and the measure of angle B is 66 degrees, then we want to find the remaining side and angles. So we are going to be looking for side C and then angle A and C. So we do have our corresponding angle and side being angle B and side B. But here is a side-side angle triangle, so we do need to look for that ambiguous case. Okay, so for this one, let's start by finding angle A since we have side A. So I have sine 66 degrees over 30.12 is equal to sine A over 29.45. Okay, so we just cross multiply. So I have 29.45 times sine 66 is equal to 30.12 sine A. Okay, let's just divide. So I've got 29.45 sine 66 divided by 30.12 is equal to sine A. So if we type that into our calculator, we should end up that sine A is equal to 0.893. Okay, but I have to take the arc sine to find the measure of the angle. So arc sine of 0.893 is going to be equal to A. So angle A is going to be approximately 63.3 degrees. Okay, so then we can find our angle C, again, just by taking 180 and subtracting 66 and subtracting 63.3, and we find out that angle C is going to be equal to 50.7 degrees. Okay, so now we can find side C. So start with our given information. Sine 66 over 30.12 is equal to sine 50.7 over C. Okay, so when we cross multiply and solve, we should get that C is approximately 25.5 centimeters. Okay, but this is the one where we have that ambiguous case since it's side-side angle. So we had found, so I'm going to just draw a little, we had found that sine is positive in quadrant 1, but it's also positive in quadrant 2. Okay, so we need to determine where else sine is going to be equal to 0.893. So if we recall back from chapter 9, how we find that would be by taking 180 and subtracting out what we originally found for angle A, which was 63.3 degrees. Because remember, now we're in quadrant 2. So this time, angle A is going to be equal to 116.7 degrees. Okay, so if that's true for angle A, then we have to find out what angle C is equal to. And so we would take 180, subtract the 66 degrees for angle B, and subtract 116.7 degrees for angle A. That tells us that angle C is going to be negative 2.7 degrees. That doesn't make sense for an angle to be negative, so for this case, there is no second triangle. Okay, in number 3, we have A is 2 feet. We have side B is 6 feet. And then angle A is 23.1 degrees. So once again, this is a side angle triangle. So we do need to make sure that we're checking for that ambiguous case. So we do want to find the remaining side and angles. So we have angle A and side A. So that's the information that we are going to use. So we have sine of 23.1 over 2 is equal to sine B over 6. So we have 6 sine 23.1 is equal to 2 sine B. So let's divide by 2. Okay, so we get that sine B is equal to 1.18. Okay, so we would have to take the arc sine, but what you should notice is that sine is always between 1 and -1. So when I type this into my calculator, I get an error. Okay, so that tells me that there is no such triangle. And we are actually done with this problem. In number 4, now we have, this is A. So A is 2 feet, B is 3 feet, and angle A is 23.1. So again, this is side-side angle. So we're going to check for that ambiguous case, and we want to find the remaining side and angles. So once again, we've got angle A and side A. So we've got sine 23.1 over 2 is equal to sine B over 3. So we have 3 sine 23.1 degrees divided by 2 is going to give us sine B. Okay, so when we type that into our calculator, we should find that sine B is equal to 0.589. So when I take the arc sine of 0.589, which is between 1 and -1, we get that angle B is approximately 36.05 degrees. Okay. So now I can find angle C. So angle C is equal to 180 minus 36.05 minus 23.1. So that tells us that angle C is going to be approximately 120.85 degrees. Okay, so now I can just find side C. So always begin with our given information. So I've got sine 23.1 divided by 2 is equal to sine of 120.85 degrees divided by C. Okay, when we do our cross multiplication and we solve for C, we should find that C is going to be approximately 4.4 feet. Okay, but once again, we do have the ambiguous case. So let's find triangle number 2, or let's see if there is a second triangle. So we have that angle B. So again, sine is positive in quadrants 1 and 2. So if I'm trying to find what angle B is going to be in quadrant 2, I just take 180 degrees and I subtract out the 36.05. And this time, angle B is going to be equal to 143 degrees, or 143.95 degrees. Okay, so then to find angle C, I would take 180, subtract out angle B, and subtract out the given of angle A. And so this time, angle C is equal to 12.95 degrees. So now we can go ahead and find out what side C is going to be with our new angle C degree. So I would take sine with our given, so our 23.1 in our given side, which was 2, and that is equal to sine with our new angle C, so 12.95 degrees, and we would divide that by C. So once again, when we do some cross multiplication, we find out that C is approximately 1.1 feet. So this is one of the cases where we do actually have two triangles. Okay, and then in our last example, we do have number 5. So angle PQT is 24 degrees, and RQS is also 24 degrees, and then QRS is 48 degrees. So we want to find, we also have PT is 1 and RS is 2. We are looking to find PR. Okay, well, we do have two triangles, so we are first going to look to see if we can find out what PQ is, and then we'll see if we can figure out QR, and then just add them up. So in this first triangle, the one with PQ, that is a right triangle. So with our angle of 24 degrees, I have the adjacent side and the opposite side. Okay, so that would be tangent. So I can have tangent of 24 degrees is equal to the opposite side, which is 1, and the adjacent side, which is PQ. When we do some cross multiplication, I would have that PQ is equal to 1 divided by tangent of 24 degrees. When we type that into our calculator, we find out that PQ is 2.246 units. Okay, so I know what PQ is. Now we're going to look to see if we can figure out what QR is. So I do have an angle and a side that are across from each other, so they are corresponding. So what I can do for this one is have sine 24 all over 2. Now I want to solve for QR, so that's going to go with angle S. Okay, so we can easily find angle S by taking 180 degrees, subtracting out the 24 and subtracting out the 48. So angle S is going to be equal to 108 degrees. So in my numerator, I'll have sine of 108 degrees, and in the denominator, I'll have QR. So when we cross multiply and solve for QR, I have QR is going to be equal to 2 times sine of 108 degrees divided by sine 24 degrees. Type that into your calculator, and QR is about 4.677 units. Okay, so PR is just going to be the sum of the two. So that's going to give us 6.92 units.